Solving triangles using the law of sines, Part 2. You should be familiar with the law of sines and how it can be used to find the missing parts of triangles in the case when you are given the measure of two angles and the length of one side, either the angle-side angle or the angle-angle side case. In this lesson, we examine the ambiguous case side-side angle, which may give two possible answers. Here's an example of the type of problem we wish to solve. We are given the lengths of two sides of a triangle and one angle which is not between the two sides. Know that there is no guarantee that side A goes down and to the right from vertex B. It may go down and to the left. In this animation, we are given the angle formed by the blue and black sides, which will stay fixed. We are also given the lengths of the blue side and the red side. We will need to find the angle formed by the blue and red sides, the angle formed by the red and black sides, and the length of the black side. We will swing the red side back and forth until it touches the black side. This will determine the two angles involving the red side and the necessary length of the black side. There are three cases. Sometimes the side opposite the given angle is too small and will not reach the far side. In this case, there will be no solutions. Sometimes the opposite side is so long that we will get one solution on the right, but miss the black side on the left. Sometimes the opposite side is just the right length, so we get two solutions. One solution has an angle less than 90 degrees, where the red side meets the black side. The other solution has an angle larger than 90 degrees, where the red side meets the black side. Returning to our example, we can use the law of sines to find angle C with one bit of caution. The inverse sine function gives you the angle in the first quadrant with the appropriate sine value. There is also an angle in the second quadrant with the same sine value. To get the second angle, subtract the first quadrant angle from 180 degrees. From here, we can solve both triangles, first by finding the third angle, then finding the third side using the law of sines. In some cases, the second quadrant angle will be too large and only the first quadrant angle will work. Here's an example. We use the law of sines to find the two possible angles as usual. Your calculator will give you the first quadrant angle of 44.16 degrees. We find the second quadrant angle by subtracting the first quadrant angle from 180 degrees. In this case, the second angle was too large, making the sum of angle A and angle C already over 180 degrees. Therefore, only the first triangle yields a solution. Here's a third example. In this case, the angle C has a sine value of 1.811. But we know the output of the sine function is always between -1 and 1, so there is no such angle that works and we get no solution. This is the case where the side with length 5 is too short to reach the base of the triangle. To recap, given two sides of a triangle and the angle opposite one of them, try to find the angle opposite the other using the law of sines. If the sine value is larger than 1, you will get no solution. If you do get an angle when you take the inverse sine, then also find a second quadrant angle and test the two possible triangles. Find the third angle by making the sum of the angles add to 180 degrees. When using the first quadrant angle, you are guaranteed to get a solution. When using the second quadrant angle, the sum of the first two angles may already be more than 180 degrees, in which case you will only have the one solution. You may also get a second solution from the second quadrant angle.